How you doing, Mr. Dean?
How you doing, Mr. Dean?
Doing all right. How about y'all?
Doing all right.
Just giving a couple minutes for everybody else to file in. All right, so I guess we will get started. First, a couple refreshers. All right. So the document overload that goes over the tests that we talked about right here for online tests. Like I said, those tests are posted. You have 2 different attempts. So again, remember, don't start them until you are ready to do it because they are timed, and the timer starts as soon as you open the assignment. So if you're not ready, then don't open the assignments. All right. So with that, I guess we're going to move in and start with chapter 2.2, which goes over functions. All right, so all right. So up to now, we've kind of dealt with functions, and most everyone has dealt with a function at least a little bit in real life, but may not have been able to put it into words. So that's what we're going to try to do now. So who can tell me what a function is? Give me an example of a function, or maybe even the definition if you want to, but preferably in some way that you can personally describe what is a function. I mean, it's okay if you don't know, obviously, but just curious. So one of the more common ways that you might have seen it in real life is in finances, a cost function or a interest function. So, for example, interest, you want to calculate the amount of interest that you owe. Simple interest goes like this. I equals principal times rate times time. So this is a function. And you might think, oh, well, it's just an equation. Kind of. At least that's the way we generally deal with them. But a function is kind of a set of steps where you take some input thing or multiple things and you get something out at the end. So with this equation, we input the principal, the rate, and the time. We get out something else. So the idea is a function goes from some set of inputs. This is a more technical definition. So a function takes something from the inputs, set of inputs, and what we call maps it, but turns it into something in the set of outputs. So what it does is anything that you put into that function, you'll get something out of it. All right. So this is how we generally write a function. Is a function of A. So A in this case is the input. So there are a couple rules though. Another way that you guys may have seen this is when you're talking about equations of lines. So the idea is your input is X, and then some stuff happens to X, and the thing that you get out is Y. So this is a map. This is called a map from X to Y. The idea is, quite simply, that Y is a function of X. So we usually just write it like that, but you can also write it like this. And that is to say that Y depends on X. If you change X, then it's probably going to change Y. So given this jump ahead kind of comparison, does anybody remember what all of the possible values of X are called in an equation or in a function like this? Starts with a D.
No.
So what? So the set of input is called the domain. So A is the set of numbers that is the domain of this function. So with that, set of B is the outputs. So if the inputs are the domain of the function, what are the outputs called?
Range.
What?
Range.
Range, exactly right. So this is the kind of the basic definition of what a function is. If you have some process that takes some input and gives you some output. I know it's kind of abstract at this point, but we'll get a little bit finer tuned. But we have to go over some specific kind of rules of this thing. So one of the examples that they give is the temperature outside as a function of the time of day. So everybody kind of knows this, that in the morning it's cool, as the day goes on it gets hotter, and then it starts to cool back off. So time and temperature. We've labeled a couple times here. And we're going to have some temperatures over here. So let's say 60, 65, 70, 75, 80, 85, 90, 90. All right, so hold on, let me turn this overhead light on. Maybe that'll help. All right. So when it's 1 o'clock, that might correspond to, doesn't work. Might be 60 degrees at 1 o'clock. That can't be seen. All right. Then 2 o'clock, it's a little bit warmer, 65. 3 o'clock, 70. 4 o'clock, it starts to cool down a little bit, so it stays 70. 5 o'clock, it goes to 65. And 6 o'clock, it's back down to 60. So I know that there's a lot looking going on here, but this is kind of, let's say, how the temperature actually works throughout the day. So there's a couple things to notice here. What are there any observations, I guess, from the crowd about how this stuff ended up, how my lines ended up getting drawn or anything like that? Just to there's no difference between the color. I mean, I guess you could say that the green is when it's starting to cool down. But look at the inputs and the outputs. Is there anything that's maybe interesting? No, that's good. So to be in the domain, to be an input, every number that's in the domain has to go to some number on the temperature side. If it's in the domain, it gets used. But not every number in the range will get used. You can't go from every number over here and get to, from any number over here and get to 80 or 85 or anything. So they are not used as outputs, even though they are over there. So every input gets used, but not necessarily every output. Another thing about it is every input goes to some output. But you can have two inputs, like for this case, 1 and 6, both go to 60. 2 and 5 both go to 65, and 3 and 4 both go to 70. So you can have multiple inputs go to the same output. But you can't have one input go to two different outputs. Okay? So that's an important little distinction that we'll come up with an example for when we start talking about lines and figures, everything in a little bit. But this is the idea. This is kind of how functions work. So to write these rules, actually, we'll just do it like this. So each element in A must match with an element in B. So that's the first rule we talked about, where everything in A gets matched with B somehow. Some elements in B may not get matched with an element in A. So all of this stuff in the outputs doesn't necessarily get connected. Characteristic number 3, 2 or more elements in A can go to the same element in B, meaning they go to the same output. Number 4, though, an element in A, the domain, cannot go to two different elements in B. All right, so these are those 4 little characteristics. So let's see. All right. So again, kind of back to how we represent these things. For this chapter, at least, we're going to represent them explicitly by a letter, F, and then there's going to be a little parentheses and X. You can change either letter depending on what you need. We might end up having G of Y. Okay. But the main idea is we have some function, and this is not F times X. This is F of X, meaning you put something in to the input there, and F is the thing that you get out. So let's look at, you could also have Y of X. It's a common one that you are used to. We just often don't write the Y because we know that it's going to be a function of X and we are a little lazy. So we just kind of ignore it. So let's look at how this might appear, how this might show up. So just start with a table. So we have inputs and outputs. So let's see. 1, 8, 2, 11, 3, 10, 3, 8, 4, 5, 6. That's good, Frank. So, is this a function?
No.
Does this function follow all the rules?
On the looks of it, no, because isn't the X input supposed to have only one of every number?
So the X is supposed to what?
It's supposed to have one of every number.
Yeah, so the X goes to the same X value goes to 2 different outputs. And that is a no-no. So yeah, that's actually a very interesting way of saying it, is if you were to list out all of the pairs, all of the input pair with the corresponding output, X should never be, you should never have the same number twice over here. You can have it multiple times over here, and that's fine. But you can't ever have the same number over here twice. So yeah, that's one of the ways we do this. If you're just looking at values, that is the way to do it. So how about sorry, my share button's missing. How about the example on the screen here? So this is just a graphically represented one. But does this represent a function? Why or why not?
Repeat the question, please.
So is this a function? So we looked at something like this, and this was not a function because we had these 2 X values give 2 different Y values. So what about this one? Oh, that's not. No, that's not.
It's a function.
Oh.
Because it would be a function because of -1 and 1. So,
Yeah, it is a function. It has different points, but it doesn't ever reuse an X value. So there's only one X equals 2.
Okay, I got you.
1, a negative, or 0, a -1, and a -2. But there aren't two of the same x values. There are two of the same y values. So this one and this one both have the same y value, but they have different x's. These both have the same y, and then this one's by itself. So this is valid because it doesn't have it doesn't share any x values. And so what we have when we are checking a table, we can do what was suggested earlier, which is basically just take the values in the table and say, all right, are there any duplicates in the x column? If there are, then it's not a function. But graphically, we have a very, very simple test. And I'm going to quick draw the one we just had. Think of something like that. So with functions, what we do is we do something called the vertical line test. So this is not very imaginatively named, but it is exactly what it sounds like. You take a vertical line. What's going to be my vertical line? I don't have my ruler. Where those? What you do is you take a vertical line and you move it all throughout the graph. This is a vertical line, and you see, does it ever cross more than one point? So every time it only crossed one point. And this is how you do the vertical line test. So where's my, you just make sure that it doesn't intersect more than one point. All right. So it could intersect 0 points and it's still a function. It could intersect 1 point, but it cannot intersect 2. Otherwise, like I said, it is not a function. Okay. So this is the basis of checking whether or not something is a function. So what about algebraic? All right. So is this a function? Well, solve this for y. What do you get? So when you solve this for y, you get y squared equals 1 minus x squared, and y equals 1 square root. Sorry. Thing keeps moving around. So you get square root of 1 minus x squared. Well, if this was the end of it, this would be a function. But when you take the square root of y squared over here, you get plus or minus this thing. And because you have y equals plus or minus something, that means that you do not have a function. Because you could, if you plugged in, let's say we did x equals, I don't know, 0.5, then you get y equals, let's say, yeah, then y equals plus or minus the square root of 0.75. So it's either positive that number or negative that number. We got two different y values just by plugging in a single x value. Okay, so moral of the story, not a function. All right. Well, we're probably going to get kicked off here in a minute. So, yeah, this is where we are headed. Please remember that your tests are up. So please go and take them. If you have any questions about the rules, go see that document that we outlined. Yeah, so that's all we've got today, and y'all have a good rest of your morning. We will see y'all on Wednesday.
All right, peace out. Be safe.
Okay.
Wash your
Here's
hands.
the waffle. We're baking.